So this is a video for Michael Woodrow at ABS Consultants Limited by Jersey Laser Scanning Limited. This is a video to show the workflow process of collecting a LiDAR point cloud. LiDAR stands for Laser Light Direction and Range Finding, and it's an identical concept to radar, which is radio wave direction and range finding, but it uses laser light instead. So these are all dots, these pixelated measurements that you can see. They're colorized by the panoramic imagery, which are in each of these scan points, which you can see. They're colloquially known as cheese heads because they look like Swiss cheese. And it allows people to look at the detail of render, the quality of things, which you obviously can't see quite as well in a point cloud, but the usual aspect to look at it from is this view, and it captures a very wide area. It's got quite a good range. It enables you to move through the walls, floors, ceilings and so on in this project, but I'm going to walk you onto target onto a specific area, which is a recess cupboard. So this is the recess cupboard in question. And we're looking around the rest of the room. And now we'll move into the computer-aided design software, which I use, called Revit. So this is Revit. This is a 3D computer-aided design software. It can be output to PDF, and you can see some of the more traditional views. 2D plan views. You can move into section views just by drawing a line through the property and output this instantly, since it's been created in 3D. But going to this image, the reason why it is in strange colors is this is a setting called normals for the point cloud, and it allows each plane to be colorized slightly differently. Hence it can help me pick up the edges of walls much more clearly. So a requirement for this project, which I hasten to add, was a cancelled project. So there are some unfinished areas in here. Normally there'd be mullions on the windows and windowsills, that sort of thing. Was that the sight lines of surrounding properties were to be captured, so they've all been modelled as well. So moving into the area that we wanted to look at specifically, this works slightly different from Jetstream, which is the other product which you just looked at, in that you can't move through floors and walls as such, but what you can do is something slightly different, which is cut, slice and dice the property as is necessary in order to be able to model it or view it. And this is the room in question. So looking at it from an orthographic perspective, so from above, you can see the cutout on the wall and the accuracy back to it. This is a fairly straightforward recess cupboard. It's straight in and out. Anything else like arched backs, an arch on the top, or domed on the top, or a recess which goes further back from the frame inside the wall, so the frame is here but the recess goes further back, can all be modelled. So hopefully that gives you some indication of the amount of detail captured. And the accuracy is between 3 and 9 millimeters, normally down to 3 to 4 millimeters. But once you georeference, georeferencing is the GPS coordinates to the Jersey transverse Mercator. That reduces the accuracy slightly as it tries to bend to match that, but the whole area is therefore georeferenced, meaning that each and every one of these 1.1 billion points in this particular project have their own GPS coordinate. So each one of these dots have their own GPS coordinate. The way that modelling works is that the 3D surface is created and then moved directly onto the point cloud, so just so the point cloud pokes through, and it's a manual process. There's nothing automated about it at this stage. I'm sure that may come in the future, but each of the planes then moved carefully into position. I hope that helps. Thank you very much.